Good morning, everyone. Welcome to the ECOSYSTEX Insights Series webinar today on the 29th of November. I hope all of you had a great start to the day and that you can all see my screen. Thank you for joining us. My name is Tilla Cross and I work as Sustainability Programs Officer at Textile ETP, and we are responsible for managing the ECOSYSTEX community, of which 4 member projects will present very interesting presentations to you today. Textile ETP is an organization based in Brussels whose aim is to match textile and clothing related research and innovation with the European industry needs and priorities. And I'm very happy to guide you through today's webinar. And whilst we wait for people to arrive, I would like to remind you of our webinar procedures. So this webinar is being recorded and will be shared on YouTube. If you have any questions, please type them in the chat and we will then address them during the time for the Q&A. Also for the speakers, please don't answer any questions in the chat. We will do that live during the Q&A session. And if you would like to elaborate on your question during the Q&A, please raise your hand and then we will invite you to speak. This is the agenda of today. So we have actually 5 speakers from 4 different ECOSYSTEX member projects. First, I will provide you with a short introduction to what ECOSYSTEX is, in case you're joining this webinar for the first time. Then we will hear from the WhiteCycle project, followed by 2 presentations from the CISUTAC projects. Then we'll have a Q&A to address questions to these 2 projects. And then we follow with a presentation from the SOLSTICE project and from the HEREWEAR project. And in the end, I will wrap up and highlight some next events that might be interesting for you to attend. So what actually is ECOSYSTEX? You might already be familiar with it or even a member of this community, but others might hear about it for the first time. So I'm here to recap what ECOSYSTEX is and what we actually do. So ECOSYSTEX is the European community of practice for a sustainable textile ecosystem, and it is essentially a cluster of by now 45 EU-funded textile circularity and sustainability projects. The objectives of this community are threefold. So for one, we want to foster inter-project collaboration by bringing together the knowledge and experts from all across Europe, all working together related on topics of textile sustainability. We also aim to enhance engagement with policymakers and support them in their decision and policy making by providing them with expert input. And our third objective is dissemination. So that includes dissemination activities like this webinar, where we ensure that an interested public outside the community can be informed of what is going on in the technical work of these projects. Here on the slide, you can also see some numbers to give you a better idea. So the ECOSYSTEX kicked off in January 2023, and we've been really growing every month. As I said, we have now 45 member projects and around 317 registered experts that come together in 6 different working groups to collaborate. Then we also organize these bi-monthly Insight Series webinars every other month. This is now the 11th edition. And we also organize an annual conference. This year it was in Milan, and next year in 2025 it will be in autumn in the Nordics. So if you follow us on LinkedIn, you can stay in the loop about all information regarding to that if you want to meet some of us in person. So, but now, well, I'm almost coming to the end of my short introduction. Here you can see all our member projects on one slide. So I'm very happy that 4 of them will present to you today. This is the agenda that I'm bringing back on the screen. And with that, it's time for me to invite the first speaker of today, Pauline Langbehn, to take the floor and share with us what they're working on in the WhiteCycle project.
Thank you very much, Tilla, for your nice introduction. I'm going to share my screen. 1 second. So, hello all. I'm Pauline Langbehn. I work with iPoint Systems. We are a software provider situated in Germany. Our headquarters is in Reutlingen, which is near Stuttgart, and I'm myself are sitting in Hamburg. So WhiteCycle is one of our research projects, and I have structured my presentation in two big blocks. We start with an introduction into WhiteCycle and then go further into life cycle assessment. So what is our tool? How are we working with it, and why does it support the measurement of the sustainability of recycling? So WhiteCycle. WhiteCycle is an innovative European project to process and recycle PET from tires, hoses, and multi-layer clothing at the end of their life. So the aim is to really create a circular value chain and to have like less waste. Therefore, there are innovative processes for recycling of PET complex wastes, which are meant to be upscaled. There's a case study which involves then mechanical and enzymatic sorting applied to those products like tires, textiles, and hoses. So one of our key figures, the aim is to avoid around 1.8 million tons of plastics from landfilling or incineration each year, and also to avoid about 2 million tons of CO2 emissions. In overall, there are 60 European partners which are in this project, and the aim is to reduce CO2 emissions by 2030. Here you can see an overview of our partners in the project. As you can see, we're also situated in different countries, from France to Spain and Norway, and we're all gathered together to create a more sustainable future for textiles, hoses, and tires. So what is being developed in this project? So there's a so-called WhiteCycle process. This is a recycling process which specialty is to identify and sort textiles, and also to like really identify PET in textiles, for example. Then later on, there's an enzymatic recycling process, which then enables the production of high quality yarn, which can then create new products and enables a circular and valuable value chain. So here we have a broader overview over the WhiteCycle value chain. So as I said, we start with the waste from textile hoses and tires. Then we go into the macro sorting of and identification of the product of PET. Then we go into fiber matrix and matrix separation, then into the amorphization, enzymatic depolymerization, purification, polymerization, and then into the yarn and cord production to create new products. As you can see, also our different partners are each situated in different steps along this value chain. iPoint is seen here on the left, down the left, here in the LCA, LCC, DMP, and social acceptance bracket, but we are really looking into the LCA and in LCC. So now we are going into the LCA part. So LCA is short for life cycle assessment. And how can life cycle assessment as a tool support the recycling decisions in the textile industry? So first of all, a short overview over lifecycle assessment and product carbon footprinting. This is a method to identify an environmental impact of a product, service, or over its entire life cycle. There are already some standards in place, for example, ISO 14040, 14044, and or ISO 14067. Product can be evaluate in different impact categories, for example, global warming potential, which is then a unit of CO2 equivalent, acidification, eurification, etc., to really have a whole overview over the supply chain and to be able to measure the impacts. There are secondary databases, for example, EcoInvent or Carbon Mines, where you can like map data sets to certain entries, which is also a big part of an LCA. There are different system boundaries within an LCA which we can look at, for example, cradle to grave or cradle to gate. Here on the right-hand side, we see a life cycle, and cradle to grave would be like to take a look at a product from raw material extraction till the end of life, so including recycling processes or waste incineration or landfill. And cradle to gate would be like to start from raw material extraction just after a product leaves the factory, so after part processing and before the product use. It is important also to critically review LCAs and PCFs when you're aiming for comparison and public communication. But in the end, you have a holistic view over your product when you're using an LCA. And it can help to understand trade-offs between different environmental impact categories. And which also is really good and fits to our WhiteCycle project here, is to really measure the impacts of the recycling processes being developed. So now I want to show you how an LCA can be done by our software, or how they're playing together. And we start here with a quick overview of our software. So iPoint Product Sustainability is a combination of an expert software, which is Umberto 11, and the web application Product Sustainability. Umberto 11, here on the left-hand side, you can see a small picture of a model, which would be in Umberto 11. Here, life cycle assessment models can be developed. And by using the generic modeling approach, which I also have a slide on later, different multiple product variants can be calculated with one model, which therefore can scale also LCAs. And in the end, with the model, you can calculate, of course, LCAs, so life cycle assessments, and product carbon footprints. Umberto 11 is some sort of backbone for product sustainability, because the models which you create in Umberto 11 are uploaded to product sustainability in the web application, where a large number of users can make use of such an Umberto model. And scenario analysis also by non-experts can be done, which was also already or often quite a bottleneck because LCA experts are quite rare, and by creating product sustainability, also non-experts, for example, engineers, can use it. For this, LCA results can be scaled. So here you can see another screenshot of our expert module Umberto, which is already in its 11th generation. So this is how an Umberto model can look like, and you can really also include here end of life and therefore measure its impact. So now I want to go more into the automation, which I already said, like based on our generic modeling approach. First, it always was in an LCA that we had one model. So for one product, and for scalability and to be able to calculate much more LCAs, we enable or created this generic modeling approach where one model can be used for really a lot of different variants of a product, and therefore, yeah, scale the calculation of LCAs. Also, in our product sustainability tool, we have this smart mapping feature, which enables LCA experts to, yeah, map their data, their entries of their models with LCA datasets from secondary data. Therefore, an LCA expert needs to train the system, but after training the system, also non-experts can easily map their bill of materials or short BOMs. With this, we even, yeah, we can even scale the calculation of LCAs more, and with certain verification, non-verifications, but with a certain VDA classes, for example, it is even possible to map your data sets for 100% to the right entries. So here you can see when you click on apply smart mapping, the beforehand unmapped entries are now mapped. And when you click on this one, you can see like which data sets are in the background. So just to give you a holistic overview, how a workflow at iPoint product sustainability can look like. So for example, we start with collecting data from different systems, from ERP system or CAD systems, but also imports via Excel or other systems or other data formats can be done. What is getting more and more important is also primary information, so direct primary values from suppliers, for example, or from plants where processes are taking place, which is displayed via the supply chain here on the lower left. For example, via Seagreen, we have a partnership with them where we could get from customers, we could get primary data. So after collecting all the information needed for an LCA, we can then go to the second step and to start analyzing it with our backbone Umberto. So the calculation model uploaded, and also all the information there, we can calculate different model variants and create results, which are all stored into a basic cloud system. And after having your results, you can either report it via individual reportings like Power BI or Excel exports, or you can directly stay in iPoint Product Sustainability and create different scenarios here, for example, as an engineer or designer, or also as an LCA expert. But you also can share your results via third parties like Seagreen. So here, just to give you a quick overview, I wanted to show which kind of use cases are there for product sustainability. For example, an engineer could use it because it mainly uses CAD, but with product sustainability, they can also incorporate environmental aspects to their decision making when creating products already. So also already in the design phase. Also, different materials can be used already there and looked at, which can also be important for recycling processes, because you can already like incorporate certain aspects here, which are then like later on important for recycling. Like, for example, like the word design for recycling. So already it can be quite important in the design phase. But also for comparison of BOMs and material, it's interesting for an engineer to use it. Also, management use case is quite interesting as they set KPIs, which can be measured by product sustainability when you're making changes, and also the advanced LCA user can make use of it, of course, because they can scale the calculations, and therefore the bottleneck is decreased. So I told you beforehand when we looked over the whole process that we're like how you can report, for example, your results. This is an example from our side. So, for example, business intelligence tools can be used. Here's it, Power BI, which we have an API to. So you can easily create nice dashboards and reports, which can later then shared with stakeholders. Here's also another customer example. But what is also possible to create an interface between product sustainability and a customer tool, for example, then that you have directly environmental information into customer web applications, for example, as seen here. So with this, we already come to my conclusion. So what kind of recommendations can be made based on an LCA? So I summed up some aspects here. We start with transport routes. So when we know the impact, we can optimize logistic chains, reduce transport distances if possible, or also choose for low emissions transport and really measure what kind of impact are you making here. You can also take into account different energy sources, for example, using renewable energy, also looking there, what kind of impact does it make, and also improve the energy efficiency of your product already in the design phase, and also reduce the reliance on fossil fuels. So, but also technology comparison can be made, which I somehow would say like WhiteCycle can be seen here as different processes are evaluated and also looked at how efficient they are, and therefore also recycling processes can be like really measured, and based on our results, certain decisions can be made. Different or like innovative technology can be implemented, and outdated systems can be replaced, and of course, as I said, really the impact can be displayed. Fourth, we have here material substitution. So sustainable materials can be used, and also promote recycling and reuse, and also minimize raw material consumption. At the end, we have like comparison to state-of-the-art processes. By having benchmark models of old processes, we can really compare new processes to those old benchmark processes and see the impact, see the differences, and learn from best practices. Also, identify areas for improvement, and then adopt leading standards. So we're already at the end of our presentation, my presentation. This is me and my colleague Manoj. Manoj is the one who is in charge of the WhiteCycle process, and if you have any questions regarding really specific questions, I think I would rather suggest you write an email to Manoj. And with this, I would like to thank you for your attention.
Thank you very much, Pauline, for your presentation. Very interesting and complex what you have developed. So to our audience, if you have any questions to Pauline, please type them in the chat, and then we'll address them in the Q&A. But for now, it's my pleasure to welcome Lien Van der Schueren to this webinar. And please, Lien, take the floor for the second presentation of today.
Thank you very much, Stila, and also welcome to all from my side. So it's really my pleasure to be able to present you today the update, let's say, on the CISUTAC project, which is a project which is coordinated by Centexbel. So I'm working at Centexbel as a researcher and project manager. So CISUTAC is about halfway. We started in September 2020, so we thought it's a good time to present you some of our more mature results. So already a disclaimer, what I will present today, it's not a full update of all we have been doing in the project, because of course that's not feasible in the time frame available. So please, if you have any questions or feedback, reach out to us and we can have a more detailed discussion. So first of all, what is the CISUTAC project about? So we aim to increase the circularity and sustainability of textiles in Europe. And this is being done by developing semi-automated workstations for repair and dismantling, also by working on novel recycling technologies, and by trying to understand the sector and the consumers, and also trying to change their behaviors. So we aim to actually cover quite a big part of the textile industry, and we do this by focusing mainly on two material groups, which is cotton and polyester, the two main used fibers in the textile industry. And we also focus on three different subsectors, which is fashion, workwear and personal protective equipment, and active goods. And with this, we think that actually they are quite different. All the three subsectors are quite different. They all have their specific challenges. And in this way, we aim to get a broad view on the textile industry. Of course, we are doing a lot of things within the project. So for this, we need to work together. And here you see the consortium of our projects, and each of them is bringing in specific expertise, which is required to get our objectives done. Let's then have a look to some of the results that we already obtained. And the first share of results, it's on innovations which have been done in order to increase sustainability of the textile sector. And here, a first activity was on developing a pilot for zipper repair. So at the moment, zipper repairs are mostly done using standard sewing machines, also requiring a lot of time and also a very specific expertise and knowledge skills of the person doing the repair. So within the project, PCH, our partner in Germany, they developed a semi-automated workstation, which is able to do this in a more efficient way and also not requiring really skilled operators to do the repair. So the workstations are now being piloted at two partners, which is the Kringwinkel in Antwerp and also Decathlon in Italy. So they are testing the zipper repair station. And at the moment, we obtain quite promising results. And the aim is to be able to conduct 6 repairs in 1 hour. I've also added a link in case you want to have some more information. You can click on the links. Another workstation which is also being built in the project is for personal protective equipment and trying to get the recycling of this more easy. So these personal protective equipment, they are quite complex textile structures, which is of course a challenge if we want to recycle them. However, these PPEs, they often also contain very valuable textile materials, which makes it worth to do the recycling process. So here we are focusing on firefighter suits, which contain very expensive and valuable aramid textiles. And the goal is to be able to disassemble the firefighter suit and to get the pieces of the aramid textiles out. Also here, PCH Innovations and STAM developed a workstation, which is consisting of 2 units. We have a cutting unit and unit to remove the application. And actually this application are the high visibility stripes which are present on these firefighter suits and which have to be removed if we want to recycle the aramid fibers. Also, this workstation was set up at the Kringwinkel, and actually here we try also to involve the social economy and to see how we can combine textile sustainability with the social economy. And also in this case, first results are really promising. Another topic which we worked on in CISUTAC, it's actually to think ahead and to understand what is the future, what do we think is the future of the textile industry, and how can we with CISUTAC help to get this future going into a good direction. So a first one is actually trying to understand like what will the ecosystem in textiles be in 2035. We all know about the EU textile strategy, where we want to increase sustainability in textiles, increase longevity of garments, and also help the fiber-to-fiber recycling. Of course, this is our future that we want to get to, but in order to understand how in the end it will be, it's always good to look at some different possibilities. And here we did some forecast thinking to think like how possibly will the textile industry evolve. And our partner RREUSE actually developed 4 different scenarios, being on very different angles, going from a slow fashion to a fast fashion, from a global perspective and a local perspective. And this resulted in 4 very different scenarios. Again, not time to go in detail, but I really encourage you to have a look because it's really inspiring to see how the future could possibly look like. Another fact that we developed within the project, it's a tool to actually help the sorting of the textile waste and trying to prioritize what are the data points if we want to get this sorting as efficient as possible, both towards reuse as well as recycling. And here we also took into account the changes which are there regarding, for example, the digital product passport. You can have a look to the tool and you can give it a try and of course also give us feedback. Also important to know if you are working in the textile industry, it's to know what is the current landscape of textile waste management. What is out there at the moment? What are the gaps and what do we still need to solve? For this, we prepared a report which is giving an overview of what are the waste streams, both for reuse and recycling, what are the capacities regarding sorting, also recycling, and what are the typical material compositions that we find in the textile industry. Also, this analysis actually showed that it's really important that we will have to increase substantially the capacity for collecting and sorting and also recycling if we want to get the textile industry really circular. And with this, we believe that the role of regional stakeholder networks in order to help to make this transition will be really important. And also this report is publicly available. Another topic being done in the research in the CISUTAC project is actually to prepare some shared visions and to spread them in the textile world, let's say. Here we try to advise on strategic directions to identify what are the innovation gaps and also how could CISUTAC help to already fill some of these gaps. We already published 2 shared visions, one on EPR and one on waste prevention and reduction. And in the last one, you can, for example, find some recommendations trying how we can tackle, for example, overproduction. But again, more information can be found on our website. And the last, also, if we want to get the circular behaviors really present, we have to promote them and try to keep them alive. So for this, we focused in an understanding of circular textile business models and what is out there at the moment, how can they support us. But I will not go into detail because our project partner RREUSE, Marie-Jeanne, will present this much more in detail after my slides. But in the same framework, we did develop some guidelines for local embedding because, as said already, we believe in the importance of the local actors, of the regional networks. So we also try to help them to get this done and what could be some recommendations for them. And here it's our partner ACR Plus who worked on some recommendations for local government policy makers, focusing on 3 different areas, which is the waste collection. How can this be done in a good way? Also professional textile management and public procurement guidelines, and as a last, policy instruments in order to get more sustainable consumption patterns. So this in a very quick nutshell, some of the highlights on the CISUTAC project, but as said, much more is ongoing. And of course, also interesting to see what's coming still next in the next 2 years. So we will, of course, further work on our semi-automated workstations for repair and dismantling, test them, try to optimize them. We will also work on our pilots which are being built for sorting and also pilots being built for the recycling of cotton and polyester. We are also conducting consumer behavior studies, and based on this, we will also launch campaigns for the consumers. We are developing training materials. Also, actually, ECOSYSTEX started within the CISUTAC project. So, of course, also the work on ECOSYSTEX will continue and much more to be done. So, to end, as said in the beginning, if you have any further questions, any suggestions, any ideas for cooperation, please reach out to us. We are really open to collaborate. So, thank you very much for your attention. And then I will hand over to Marie-Jeanne to tell you more about the circular business models.
Thank you very much, Lien. That was a very smooth transition. So I think we can continue right away with Marie-Jeanne.
Hello, everyone. I hope you can hear me properly and see my slides.
Yes, not in full screen, though.
I'm trying to. Okay, it should be better now.
Perfect.
Hello, nice to meet everyone, and thanks a lot to Textile ETP for this nice opportunity to present our results on the report entitled Unlocking Opportunities for Circular Business Models in Textiles, Phasing Out Linearity. Before I go more in the detail of the project, I would like to quickly introduce RREUSE and what we do. So we are the EU largest network of social enterprises that are active in repair, reuse, and recycling. We currently represent 33 members in 30 countries, and more than the half of our members work with textiles, so collecting, sorting, reusing, and repairing textiles. So that's why it's a very important waste stream for us. And what we do concretely is that we represent the interest of our members towards EU stakeholders. And by doing so, we advocate for a stronger social and circular policy framework at the EU level. So now in terms of the report's objective, so the goal of this report was to analyze and demonstrate how we can concretely scale up integrated circular business models. So having a very holistic approach to circular business models, and to be aligned with the scope of the CISUTAC project presented by Lien, we focused on repair, reuse, and recycling business models in textiles. And to understand all of these mechanisms, we first focused on the framework conditions that are managing the current circular business models in textiles. And to think forward, like how we can scale them up, we focus on the challenges and the key enablers for them with different criteria. And we conducted, obviously, literature research, but also we interviewed relevant stakeholders representing the whole value chain. So we conducted some case studies, and we ended up proposing some policy and stakeholders recommendations. Now I will drive you through the results that we achieved. On this slide, you can see kind of a very broad summary of the framework conditions. So here you see a bit the like consumer behavior, consumer appetite towards circular business models. In the middle, it's our figures on job creation. So you can see that a social enterprise creates between 20 and 35 jobs per 1,000 tons of textile collected. And at the bottom of this slide, it's the kind of the framework of the textile flows, what happened with our textiles at the moment, and it gives us a good picture of where we stand. And in the same way, you can see here the current challenges for circular business models. In this report, we realized that there are two big paradoxes in the textiles used and waste textile sector. The first one is that at the same time, we have circular business models that are trying to address the problems that are caused by linear traditional business models. And by doing so, at the same time, they compete with this same business model on the market, which have very different way of working. So it's one big, at the same time, paradox and a challenge for them to be viable. And the second paradox that we identified is that we know that we have so many used textiles, so very abundant flows, but at the same time, we have a very limited portion that is actually suitable for reuse and for feedstock for recycling. It's not essentially that suitability for reuse is not there. We also know that there is a high volume of reusable textiles, but it's more like the whole context that makes it difficult to reuse them. And especially at the moment where we know that we have a big crisis in the sector. So in this sense, this report was also very timely to address this, because it really focused on the financial viability as a challenge. We have very high upfront costs for circular business models, and at the same time, insufficient financing mechanism. So something that we feel a lot at this very right moment. And also the lack of infrastructure and lack of waste management policy implementation, just 1 month ahead of the mandatory textile collection. So the paradox here is also that we know that only reuse for the moment is the only viable circular business model, but it's in a lot of difficulty at the moment. So we must at the same time save this model, plus find ways to make a business case for recycling and repair. So a lot of challenge. Here you can see the challenges that were mentioned by the stakeholders that were interviewed. You can see that there is a great emphasis on the financial aspect, so the financial viability, access to funding, and the difficulty of accessing funding when different business models are competing, for example, for the same subsidies. The difficulty to take into account affordability to attract consumers, but at the same time remain financially viable. Innovation that is costly and adding on top of the pile of other costly operations, and the difficulty to find a solution that can fit very different type of models. But if we now look at the bright side, we also saw some opportunities to scale up circular business models. The first one is a bit basic, but I think important to take into account. It's that the more circular you go, the less linear you also go. So we can see it as a self-reinforcing process that can be enhanced by creating partnership. So basically working together towards same goals and sharing resources to progress faster. We also see that EU policies are already working on this. Like, we need to be even more ambitious, but we have kind of a good background that we can, a good ground that we can work on to improve infrastructure and find financing mechanism for circular business models. For example, the eco-design regulation, Waste Framework Directive with future extended producer responsibility schemes for textile. If we build that right, there might be strong opportunities to scale those business models. And one very important link that we also identify is the consumer aspect and the importance of making sure that in the relevant policies, but also directly when you start implementing a circular business model, that you have in mind the very final link of the chain, or like the consumers, and try to make the model adapt to them. And on this slide, you can see opportunities that were identified by the stakeholders, and they kind of match with the one from the literature. So we focused on 4 clusters: policy, technology, innovation, again, consumer behavior, and the last one I will deep dive into this because I think it's interesting. So it's the idea of having a flexible and holistic approach to circular business models. So basically, one thing that's very important it's again linked to the consumer aspect, is to make sure that the solution provided is very convenient for the one that it will serve. And that could be enhanced via using digitalization, for example. Going digital can facilitate processes, but it can also make the offering more attractive. For example, online resale can be a solution for the reuse business models to attract a brighter audience. But also like circular business models for like repair, reuse, and recycling, they need very different solutions, but at the same time they can be complementary. For example, reuse and repair is a good example. You might need some repair operation to get back an item to be in a condition to be reused. So it's important to think also in this in a holistic way. And again, rely on partnership and skill development. And finally, as I mentioned, we developed some policy recommendations that I will present now. We also clustered them in 4 different categories. The first one being, I think, the most important one. So addressing the roots of the problem, which is overproduction and fast fashion. And this, we can do it within the means that we have, the policy means, for example. We can use the extended producer responsibility schemes to have strong eco-modulation practices that tackle also the volume produced, and incentivize lower production and best practices in the industry. Then the second one is investment in innovation and infrastructure. So we know that for the moment we still lack a lot of sorting capacities in Europe, but also, as I mentioned at the beginning of the presentation, with the crisis, we need to invest even in like storage capacities. So locally builds the infrastructure. The third aspect that we identify is that there is a big opportunity in boosting green public procurement. We know that public procurement accounts for 14% of the EU's GDP. So here we can really play with the public purchase to make sure that they prioritize reused products and recycled materials. Huge opportunity here. And the final one is using tax incentives to foster circular services. A good example is reduce or completely eliminate VAT on repair services and reuse products. This way, it could fix one of the challenges that we highlighted, which is the difficult balance between affordability of the solution provided and being financially viable. So that was it for my presentation, and I invite you to see the report here. It's both on RREUSE website and CISUTAC website. Thank you for your attention.
Thank you very much, Marie-Jeanne, for this very interesting presentation. I invite you to stay with us for the short Q&A session that we have now. Also, yes, Lien, you're back, and Pauline as well. So if you have any questions to Pauline, Lien, or Marie-Jeanne, please feel free to type them in the chat. I'll have a look at what's there already. So there are 2 questions for Lien so far. The first one from Stefan is, when dismantling PPE of high value, I assume an easier pilot with high value components. Could this be later used for more simple clothing? Details. It is assumed to disassemble certain elements for reuse because those components, at least majority, are not yet at the end of lifetime.
Yes, thanks a lot for the question. And it's very correct what he says, that of course the disassembly at the moment, it makes the most sense if you can retrieve high value, expensive textile fibers like the aramid fibers. But we do believe that the technology can also be used to, for example, cut out zippers or buttons from the recycled garments, and then these could go into sorting. So we already used some of the insights that we obtained with the workstation to, for example, sort out the polyester rich fraction. So indeed, it's feasible, but from an economic point of view, at the moment, it makes the most sense to do it for the high-value textile fibers. And the second question about reuse, yes, indeed, not all of the components should go to recycling. Some of them could also go to reuse, but it's something that we are still checking and developing.
Thanks for your answer. And I'm going right to the second question to you, Lien. Frédéric, is the semi-automated repair station a prototype, or can it already be developed in local, regionally, eventually shared spaces?
Yes. Yeah, also thanks for that question. So at the moment, we have two repair stations which are running and we are testing. They obtain quite promising results. And we are still, depending on what we obtain with the testing phase, we will do some optimizations to the repair workstation. And once this is done, actually, it's ready to be also spread around and to go to other places as well. But we are now working a bit still on optimization. But for sure, it could go also to other sites.
Thanks, Lien. And now I have a question for you, Marie-Jeanne, also from Stefan. He says, thanks for this important work. You mentioned a high percentage, over 50% of collected textiles that can basically be reused. You mentioned several challenges. How is this further influenced by A, the new mandatory collection of all textile waste, which will probably reduce this proportion, and B, by the psychological pressures in our today's society, i.e. the well-developed social scoring by fashion?
Thank you for this question. And yes, it's actually very important because indeed one of the challenges that we see is that we really welcome of course, the mandatory separate collection of textiles, but we also anticipate that it will create more pressure. As I said, we lack infrastructure, and now we will have to collect more. But we also know that we will have to collect not only the reusable fraction, but the non-reusable fraction. So the proportion that is currently available for reuse will be even smaller in this overall new collected volumes. And at the same time, the business model for reuse, as they work for the moment, is that they are viable thanks to this reusable fraction, which will, as I said, in the future be smaller. So we have to think, how can we still maintain these business models in the new system? So that's why we have the EPR schemes that is coming into play to finance this overall collection. But we also know that we have a time gap between like next month, basically, and the implementation of these EPR schemes, plus the thing that I mentioned, this huge crisis that we face in the sector. So that's a very important question that we need to address, like what do we do right now with this? And then in terms of the point B, the psychological pressure, I'm not sure that I understand this one. So I don't know if Stefan wants to take the floor and explain more.
Stefan, you should be able to speak now and unmute yourself if you want to elaborate. Well, if not, maybe we can do that after a second question that was addressed to you, Marie-Jeanne, and see if Stefan is still there. The second question was, could you explain or illustrate what you mean when you say scaling circular business models is a self-reinforcing process?
Yes, sure. So as I said throughout the presentation, and the goal of this report is to have a very holistic angle and view on the sector. So trying to think of like not only how can we scale up certain initiative, but really like how can we basically move the textile value chain from linear to circular. And the idea there is that all the initiative that can improve the circularity of the value chain will build upon new initiative that can like basically transform the current system that we have. And it's related to the fact that we need to think in terms of not like competing initiative, but that can support each other. That's what I meant also with like the complementarity between different type of business models. But it's also the complementarity between the type of like different type of actors that will offer different solutions. So also basically the idea that we need all of these solutions. Yeah, I hope this answered the question.
Thank you so much. And then we'll take the last question from Lola before we move on to the next presentation, so we stay in time. So Lola asked, I was wondering if you are also exploring the sustainability aspects, environmental, economic, and social impacts of the various circular economy strategies when applied to specific industries.
Yes, so as I presented reuse in the beginning of the presentation, our two focuses are the circular economy aspect and the social economy aspect. So our team works on those like two big stream of policies, and what's most important for us is to make sure that every time we work on circular policies, we have in mind the social aspect. So in terms of, for example, job creation, skills development, upskilling, reskilling, how can we improve social and economical policies. And likewise, when we work on the social economical phase, we always keep in mind the circular and environmental aspect. I don't know if it was exactly your question, but so to answer, the short answer is yes.
Great. Thank you so much to all our speakers for staying here for this Q&A. And now in the interest of time, I would like to move on and invite the next speaker, Estelle from Axel'One, to present to us the SOLSTICE project.
Thank you, Tila. I'm going to share my screen. Can you see it?
Yes, perfect.
Perfect. Thank you all, everybody. So I'm going to present the SOLSTICE project. First of all, because probably some of you might not know Axel'One, we are a collaborative platform dedicated to chemistry and environment. We are a non-profit organism. Our role is to help companies, startups, and small companies to scale up their process. By that, we are giving them several services, hosting services for them to install their pilots in laboratory or technological role, but we also offer R&D services within the context of collaborative project and in B2B. And we can also, we do have access to shared tools that are dedicated to the scale-up and prototyping on the whole value chain. Don't hesitate to check our new catalog that is online. And we've got 3 sites in Lyon area. Our R&D expertise is focused on smart process, synthesis of polymer and transformation of polymer, and process and divided solid. I won't go into too many details, but don't hesitate to contact me if you've got more question about our structure. But this leads to SOLSTICE project. We are coordinating this European project, which started 6-7 months ago in May of this year. The idea of this project is to develop a systemic solution for the circular textile economy. The project will last 42 months, and the budget is of 10 million euros, and it's funded under Horizon Europe. So regarding the solution that we aim to develop within this project, is first to address the key social and technical challenges within the textile industry. We aim to develop in 4 European regions 4 demonstrations of how we can implement a climate neutral practice and the transition towards a circular economy specifically tailored for the textile sector. So our comprehensive approach encompasses all stages of waste prevention and management, guided by a systemic 5R strategy: refuse, reduce, reuse, repair, and repurpose and recycle. So when we cascade those approach, refuse, reduce, first of all, the best waste is the waste that is not generated at all. So during the scope of the project, we aim to engage across the whole textile value chain the citizen awareness about the behavior on our habit faced to clothing approach. The reuse, we aim also to develop guidelines on sorting for resale, and also, most of all, encourage consumer to extend the lifespan of clothing by returning unused item to collection points. We know that 70% of wardrobe remain underutilized, and billions of tons of textiles waste are discarded annually, ending up to landfill or incinerated. The repair aspect is going to be tackled also during the length of the project. By promoting or facilitating the networking on self-repair service companies and other stakeholders that already exist within the region of demonstration. But the idea is to consolidate this network in order to form partnerships, long-term partnerships, in order to promote clothing repair initiative. The recycle aspect will be tackled within 4 demonstrators that will work on 4 chemical recycling technologies. At the moment, those technologies are at maturity level between 3 and 4, and the idea is to scale it up to a maturity level around 5 and 6. These processes that will be developed aims to reincorporate directly onto the whole value chain of the clothing. So we will use business case to facilitate this transition. And the last one is the repurpose. So if the textile cannot be repaired or cannot be reused, then we aim to explore options, certain alternative solutions, in order to repurpose this waste and not letting it end in landfill or incinerated. So our strategic target for a sustainable transformation of the textile whole value chain is first to minimize and transform the textile waste into a renewable resource for the EU textile industry, to boost the value of newly collected textile waste through smart sorting, to highlight the reusability of textile polymer, coating, and high-value plastics through chemical recycling, to analyze the benefits of better textile collection, sorting, and recycling, and facilitating the adoption of solutions across the whole value chain, and to enable the broad implementation of SOLSTICE solution, because at the end of the project, the idea is to take the best solution and the best guidelines that we will develop during the project in order to disseminate it on other polymers, other cities and regions. So we aim to support the transformation through infrastructure and service. The 4 demonstrators, 4 cities and regions are part of the project. Grenoble for France, Berlin for Germany, Prato for Italy, and Catalonia for Spain. So these demonstrations will serve as living laboratories, allowing us to test and refine our innovative fiber approach in real-world settings. And in each territory, Solstice will collaborate closely with local stakeholders, including businesses, government agencies, academic institutions, and community organizations. We are 24 partners working for the project. You've got the list of the partners that is plotted here. And I will go into more detail on the project methodology. So as I was mentioning, we are only at M6, M7. So at the moment, I will not present any results, but this is where we started to work on. So we can, I will put my light, yeah. So this slide is quite heavy, but it allows to have an overview on the different aspects that will be tackled during the project. So we start from the 3R, refuse, reduce, reuse, repair, and repurpose, that will be evaluated by our colleague and our partners in this project related to the social aspect and the local community. So we've got Grenoble Métropole, GenCat for Spain, Community Prato, and Circular Berlin for Germany. And circular economy, they will all work together on those best approach in order to improve, comparing to the current state, how we can have a better approach on the reduction, reuse, repair, and repurpose of our textile. The sorting and the collection of the waste will be done by our partners Alia and Pelanc. So Alia will collect the waste, the textile waste, and Pelanc will sort it by hyperspectral camera, near infrared and medium infrared technology, and also based on AI tools that will be implemented, that are implemented on the sorting line in order to have a more efficient way to sort the textile. Then once those textiles are sorted, they will be sent to the partners that will work on the chemical recycling. So we've got GITF that will work on polyamide recycling, chemical recycling. LATET will work on recycling of polyurethane. NTT will work on recycling elastane, and Recyclelite will work on polyester. Each partner in each region are in collaboration with other partners, Chromogenia and Dresmat, Fossurber, Technotext, Dengue, Spinpet, and EFTH and Axel'One, in order to improve and to facilitate the scale-up of the technology. When we speak about chemical recycling, in general, I won't go into too many details, but in general, we speak about depolymerization, dissolution, and increase of the solubility. So either we can recover the monomer, either we recover elastomer that will be directly reinjected in the production chain. So we can get rid of the open loop approach and directly create a closed loop approach from the materials that will be recovered. So the idea is to demonstrate an optimized process that is designed for those key textile polymers. And when we speak about closed loop, we cannot speak about traceability, and this is going to be developed by one of our partners at the University of Lyon, and he will work on a mineral textile profile in order to facilitate the identification and the establishment of the digital product passport. And last but not least is also the assessment, the technological and economical assessment of such technologies, because the idea is to develop those technologies with a high added value. And the first one is to have a LCA that is positive compared to the existing solutions. So this is a holistic evaluation of our new concept for recyclability of textile and plastic, because obviously we are speaking about textile because this is a huge industry, and we already know which impact it has on our economy. But the idea is also to deploy it to other products that are based on such polymers. So at the end, we focus to feed all those information, to submit guidelines and to find synergies. So we are also part of CCRI, which is a Circular Cities and Region initiative, in order also to facilitate the connection with other initiatives that works on circular economy. And the dissemination and the stakeholder engagement outreach cannot be done by our partner ETP, Tectera, Polymeris, and Text4, that will facilitate the dissemination and the replication to other regions and other polymers at the end of the project. And last, the project management is done by Axel'One, but we are also helped by a Lyon Ingénierie project on that aspect. And the last slide is the structure itself. So we've got 8 work packages. So, well, beyond the project management, we've got the current state analysis and joint design phase that is led by Circle Economy. So they will establish the initial state in terms of flow, in terms of waste generated, but dedicated to each demonstration regions, in order to have like a reference. And through the project, we will move on to evaluate the impact of the solution that will be developed during the project, and to see what shifts can be done comparing to the analysis that is ongoing right now. Then the VP3 will tackle the refuse, reduce, reuse, repair, and repurpose, and it will be led by Grenoble-Alpes Métropole. And we will focus on finding a solution of facilitating the deployment of a solution that can be done on those 4 R's. The recycling will be done in the VP4 and is led by Pauline, and the VP5 is the work package that will lead that will tackle the chemical recycling aspect, and will focus on developing the pilots and demonstrate the user case, and it is led by LATAT. And the VP6 aims to integrate and to evaluate the assessment on the sustainability through LCA and socio and techno-economic approach. And the impact maximization will be done in 2 work packages. The VP7 will be led by an entity regarding the replication and the exploitation of the results, and ETP is leading the VP8 regarding the dissemination, communication, and outreach and data management. So don't hesitate to register to the Solstice project newsletter that you can find on our website and on the QR code. You can follow us on LinkedIn as well. And yeah, I don't know the time if it's okay or not, but yes, I think that's all for me. So don't hesitate to ask me any question.
Exactly. Thank you very much, Estelle, for introducing the Solstice project to our audience. And indeed, if you have any questions about this project, please type them in the chat, and then hopefully we'll have some time for Q&A afterwards. And now it's my pleasure to welcome Guy on stage to share with us what they've been working on in the HEREWEAR project. We can already see the slides. Yes.
Good morning.
Good morning.
Also,
perfect.
From my side, good morning to all. And it's really nice to be able to present the HEREWEAR project now, because actually last month we ended. So we think it's really a good moment to give you an overview of the results. As you can see here on the picture, we managed to make some textile prototypes, the garments that are really bio-based and that offer a good alternative for currently used polyester and cotton. And next to the actual, let's say, fibers, we also looked into the elements of printing and coating. And of course, for us, with the project, it's an end. But what we also really hope and want to still further work to is that it's part of a new beginning. And that is, of course, that we go to more bio-based textile sector so that we can use renewable materials, but also, yeah, let's say the broader framing, how to bring this about. But before looking into that aspect, I would like to first say how we got there. And so here, where it's basically a European project, as said, it's still a Horizon 2020. And so our main goal, what we wanted to bring, is that we said we want to enable the textile sector to go more bio-based, but that bio-based on itself would probably be very difficult. And so that we also linked it to the aspect of more local manufacturing and also a more circular use of the textile materials so that we get to a more sustainable situation. And to put that graphically, you see here the 2 maps. On the left side, the current situation, which I think you know all very well. So we have the typical use of the oil-based materials, the cotton, it's grown typically far away. The garments are even produced further away and then shipped to us for the linear use. So what we said is what we would like to work to is more circular use of the materials with local available biomass. Since we are a European project, we just also explicitly like to acknowledge the support that we got through Horizon 2020. Here's some more details about the project. Maybe the most interesting, to give you an idea, we got a little bit more than 6 million euro funding for this 4-year project. And when I say we, then of course it goes much broader than just Centexbel, who was coordinating the project, but we had a partnership with several partners. You can see the logos there on the right part of the slide. So I think we had a very nice mix of some textile research institutes, also institutes from a bit outside the textile world, and then quite some companies, both from manufacturing side, but also offering supporting services to companies, for example, for helping with design or with manufacturing. And now, as mentioned in the beginning, to go bio-based, we had from the very beginning of the proposal, I would say, the view that it does not work to, let's say, somewhere in the value chain, replace a classical material with a bio-based one, but that one really needs to work at the level of the value chain and consider it completely. And so that's now what I would like to do, to present you some of the results that we obtained at different steps along the value chain. as mentioned, one of the key goals is to use bio-based materials. So that means, of course, that we need to have, first of all, these raw materials. And if we want to do that with bio-based materials, then the typical step is to have a kind of biorefinery. So the first question is, what input materials are there fit? Well, in principle, any type of biomass can be used, and people are also exploring various options for this. You can see here a lot of different topics. I think one of the key things is that on the one side, one can really grow specific crops to use into the biorefinery process. But what is probably much more interesting, and definitely more from sustainability view, more interesting, is if one can use currently waste products or some side streams that have very low value. Now, how do you biorefine? Well, very simplified way of presenting it is you have the biomass, and then you do a kind of first step, which is a pre-treatment, pre-extraction step. Then there is the actual fractionation. So that means that the biomass is split into its different components. And then for the components that you want to work further with, that you need, you can still do a post-treatment and upgrading to further improve the quality. So what did we do within HEREWEAR? Well, first of all, we also tried the part of, let's say, the real waste, and we looked into cow manure. Unfortunately, that seemed very difficult to process, and so the fractionation was not successful. Another type of biomass we considered are seaweeds. Different types were explored, and there we see that, yes, the biorefinery worked, but the amount of cellulose in the resulting pulp was actually too low, was too limited to make it an interesting source. Then we also looked at two more materials, that sunflower stalks and rice straw. And there we saw that, yes, one can make a pulp, but the quality of the pulp, its composition was not interesting, was, let's say, insufficient for making filaments. And what we also looked into was wheat straw, and that one was luckily successful. So based on wheat straw, we could make a high quality dissolving pulp fit for extrusion of filaments. And a little bit more about the wheat straw part. So you see here in the bottom the steps from the biorefinery process, and the graph shows the different components in the biomass at these different steps. So what we're of course interested in is the cellulose part, because that's what's being used for the spinning afterwards. And then you can see that in the initial biomass, there is a bit more than 30% of cellulose in the material, together with quite some other components. And then when, let's see, at the end of the biorefinery, one can get to a pulp which has more than 90% of cellulose, which is, let's say, a condition that is really required for the spinning. And one more important part here is what is the so-called ash content of the material. So that's some inorganic matter. You can see that in the initial biomass, there's quite some of it, so more than 10%, but in the final pulp, we could reduce it to below 1%, and that makes it possible to spin this material. So now let's say we have the raw material, and that brings to the second, let's say, group in the value chain, meaning from the raw material going over spinning to then making yarns and actual fabrics. So one of the more, I would say, traditional textile parts of the value chain. And so if we continue, first of all, with the cellulose, then we saw that with this material that was obtained from wheat straw, one could make, I would say, very nice filaments. You can see them here on the top picture. One of the specific aspects of the wheat straw was that it results in quite shiny filaments, and that was really liked by the designers in the project. So in that sense, from an aesthetical viewpoint, very interesting. And as you can also see, one can get a different shade in the color, and that depends on the bleaching of the pulp. Of course, also important is if the properties of the filaments are fit for garment making. And you can see here on the slide, we have some things about the fineness of the filament, the strength, the elongation, and so. And so the basic thing is that with the process that our partner, the ITF, used, this specific technology, the hypercell technology, one can go from the pulp to filaments that are fit for, or should in principle be fit for making clothing. And so we took these filaments also one step further, meaning making the fabrics can be done with weaving, with knitting. But all works very well. One of the aspects that we also looked into was the biodegradability. And for this type of cellulose that works in a marine environment. So that's quite important if you think of the microparticles released from textiles. It means in this case, they should not give an issue because relatively quick, they should be biodegraded. And also an aspect that was checked was the respinning of the material. So if it comes at end of life, that the material can be reused in the same process. So that means that we developed a quite good alternative for the currently used cotton, and one that is also cellulose based, but that from the environmental impact, because it can be used from different biomasses, should have an advantage. In the project, we also looked for an alternative for the currently used polyester, so which is fossil based, and we did it by looking into different bio-based polyesters. And so with the same principle as with the cellulose material, we try to look into making the filaments. And so in this case, it's with a melt spinning process, and we could obtain filaments that are very well fit for clothing. You see again some of the properties, the strength and so on. Also aspects like, for example, the sweat resistance, which can be quite important for clothing, it was okay. One of the limiting factors is still the washing resistance. So that's only up to about 40 degrees. Also, the coloring of the filaments could be done. There are quite some commercial already available materials that help there. And also, just like with the cellulose, it could be shown that the material can be recycled, that it's fit for multiple cycles in spinning. Then next to the filaments, similar as with the cellulose, we also looked into the fabric making. And so that can be done. You can knit, weave, if you, let's say, adjust the process in the right way, that can be done. One of the aspects we encountered there is that PLA tends to be a bit more brittle. So also the fabrics obtained were not as soft as one would like. And for tuning there, the softness of the fabric, we blended the PLA with other bio-based polyesters. And as you can see in the table here below, we could get to a level that is actually better than the polyester reference. So in that sense, it's also a property that can be improved and where we can get good results for going to clothing applications. So that means that we have the fabrics, we can have cellulose-based alternatives, we have alternatives for the classical polyester fiber. And if we look in the value chain, I would say one further important part is also that fabrics are typically not used as is, but undergo a further finishing, a coating step, and so on. And there we also looked into different things. One aspect was about the printing on the fabrics, where we used the screen printing technology with bio-based inks. And as you can hopefully also agree from the pictures, we could get good results there. So also with respect to the abrasion resistance, that's very well. The fabrics remain flexible and so on. Again, the washing resistance is a bit on the lower side. And next to this printing, we also looked into the bio-based coating. There we also use different types of bio-based polyester. And then you can obtain coated textile materials that, again, have a very good abrasion resistance. So in this case, one can think of applications like the artificial leather or vegan leather. For example, replacing typical materials like PVC there. You can get a good flexibility, which is really a challenge with the bio-based polyesters. So one needs to do the tuning of the coating formulations. What we can also tune is the biodegradability, because sometimes it's wanted, for other applications not. So also there are some options. And also the basic coating formulation can be further functionalized as needed. So with that, we took another step in the value chain. Then, of course, there are some more aspects. But one thing I would still like to highlight here is the aspect of design. Because as mentioned in the beginning, we assumed, and that turned also out to be correct, you cannot just simply, let's say, replace a material and hope for the rest you have all the same properties. So that means that when you do the design, when you switch from a classical to a bio-based material, you need to take it into account. But actually with HEREWEAR, the conclusion was that one has to consider it in design a much broader framework and really start from systems thinking. Because as I said, it is one thing to account for the material, but also if you want to get really the sustainable textile items, and we see that then as having it or enabling a circular use of the materials, also having a more local manufacturing, maybe tapping into the social economy for certain aspects, you all have to take that into account into the design. And so from HEREWEAR side, 10 concrete guidelines were produced, the so-called Bio 10. They cover different elements of the design. I will not go into detail here. Just two things I want to, or a couple of things I want to highlight is on the one side, even if you make the product fit for circular use, at a certain moment you will come to end of life. So this design for recycling, the number 4, is a key one. On the other hand, if you want to go to sustainable products, a key aspect is also to ensure that the items produced can last longer, have a more or fit for a more intensive use. So then we come with elements like design for longevity, the number 7, or like design for sharing, it is indicated there with number 9. So there are really a lot of different aspects that in our view should be taken into account to really get, let's say, or to reach the most sustainable products, and also to make, let's say, the best use of the bio-based material. And next to these 10 guidelines, that is, let's say, can be checked, and they're also available on the HEREWEAR Resources Hub, which I'll come back to in a couple of minutes. We also developed some software that was done by Circular Fashion, and there's a, I would say, very hands-on software package that helps designers in different steps. First of all, to help to see what's all out there, to explore opportunities, then also to give more concrete guidance, so kind of inspiration tool. And then also once the design is, let's say, more coming to an end, to have a clear checklist of criteria that should be fulfilled to really have it, to make sure it's really circular, it fits with sustainability. And so by bringing all this together, as shown in the beginning, we were able to come to garment prototypes. They were made in some units, and the companies involved in this are really still working to make commercial products out of that. Of course, one of the key things is also more in general with the project, what we did. Are these findings, will it be enough? Can we think, can we look forward to a more bio-based textile sector? And in order to answer that question, I think first of all, we should look what is out there outside the consortium going on, but especially also what is going on from the side of bio-based products. And that's important because I think you all are well aware how many textiles are produced. And I think the exact number is maybe less relevant, but it's well over 100 million tons of materials that are yearly transferred into textile fibers. Of course, the biggest bulk there is the polyester. There's also some other. Just this figure, what it exactly is, but well over 100 million. I think it's very difficult to grasp how much that is. And if you then look at, for example, the worldwide production capacity for bioplastics, then you see here on the graph that it's for the last years, there's still an estimate and it's growing, but let's say it's roughly on the order of 3 to 5 million tons, maybe in some years going above 6 million tons. But still, this is the total production capacity. It's much, much smaller than what is needed for textiles. And so from this global production capacity of bioplastics, only a small fraction goes to textiles. A lot goes, for example, to packaging. So that means that if you look currently at the bio-based shares, when we look, for example, for polyester, it's 0.01% is the estimate. For polyamide, it's higher, but it's still less than 0.5%. So I think there we have to be realistic that even though the bioplastics production scale will increase and quite strongly increase, it is still only, let's say, marginal what can be done with these materials into textiles. So how do we see it that we would like to continue and how to make the best of these results? As mentioned, the companies involved, they really want to go on and they will try to have their own commercial sets. If you look a bit broader, then during the HEREWEAR project, he started a community of, let's say, people interested in this aspect of going bio-based, but also more widely into the sustainable manufacturing of textiles in Europe. And this community will continue thanks to the TCBL Foundation. And so I would say if you're interested in this type of things, please have a look at it. So that about, let's say, keeping the actors. The other thing that we will do is, as mentioned in the beginning, sorry, it was too quick. We also have a lot of results, and we explicitly made these publicly available, and that is in the HEREWEAR Hub. So here just a couple of screenshots, and what you can find there is a lot of resources. So in a summarized form, our results, and then also with links to more detailed information. Most is publicly available. For some, we ask to sign up to the community. And next to the actual resources, there are also over 40 people with their contacts that one way or another are, let's say, expert in specific aspect of what we did in the project. So also there, I would say, if there's some interest, please use the QR code. Feel free to explore this. And then the last part, what we did also is, of course, phrase some recommendations, predominantly towards policymakers, but I think some things are also more valid for, I would say, anybody involved in the textile sector. Good to know. Some things might be maybe a bit more typical, like make sure to raise awareness outside the typical textile stakeholders. But also some things I would like to focus on here is that, first of all, it's important, especially for policymakers, to have this alignment of different policies, because here we talk about the textile sector, but it's, for example, closely linked with also agriculture, because that's from where the biomass comes. I think another one, we will need the support for this local and social. And one thing also was mentioned earlier in the presentation of CISUTAC, the lead by example, the possibility for public procurement, but I think it also just holds for all of us this aspect of leading by example when it comes to sustainable textile. And so with that, some of the concluding words. So first of all, when we look at it a bit more from the fact that we need the biomass, that we need the bio-based polymers, that means that we need to build novel value chain, the links with the biorefinery, and that also there we have to be realistic. It's still limited production capacity if we compare to the total worldwide need for textiles. On the other hand, the amounts given, I think, can already enable a lot for maybe a bit smaller scale. I'll come back to that in a second. Then also when we look into the uptake of bio-based materials products into the textile value chain, I think they're very valuable and very interesting alternatives for the current polyester, for the current cotton, and also from the side of the finishing, be it printing, coating, also dyeing, what was not really talked on here in the presentation, but there, I think, high potential for bio-based materials for various textile applications. One thing to be aware of is that most often it's not simply one-to-one replacement, so that one really needs to consider the full value chain asset, and especially also the central role design can play there. And when it comes then to go to market and to see what can be done with bio-based materials, I think the good thing is that HEREWEAR is definitely not alone. Just show here the example of one of the best products that was selected at ISPO. It's actually 100% PLA t-shirt. So not directly related to the project, but I think it shows that also others make the same conclusion, that with bio-based one can really do something. And to come back to the beginning slides, that's how I would like to end. I think it's really the materials developed are mature enough, are, let's say, ready to be used also in commercial products, even if it will be in some targeted segments and not for just any type of textile. Thank you.
Thank you very much, Guy, for your interesting presentation about all the work that you've done in the HEREWEAR project. And there are already quite a few questions to you in the chat, and I know we will run over time, but I don't want to take away the opportunity for our audience to ask questions, so I'll address them and then wrap up quickly. So the first question is, what is the original feedstock for the PLA?
For the moment, it often is still corn related, because that's, let's say, historically the thing. And now people are more and more also looking into what they call the secondary biomass. So that means that it can be side streams that can come from different areas. So there's really a lot ongoing with that respect.
Okay, thank you. And then the second question is, for bio-based cellulosic fiber based on straw, you describe using filaments for fabric. Are you aware that filaments is hardly used in clothing due to missing hairiness, and comparison with cotton fails in this aspect? Has spinning as staple fibers as well been tested?
Within the project, it was one of the things that was mentioned, but that we not explicitly pursue. But what we did is look indeed into the yarn making, into different options. And also one of the elements was that for the project, a key part was also to reduce microplastics. So removal of, I would say, in general, any microparticles. And so in that sense, also the use of the filament yarns was one of the, let's say, more maybe appropriate ways to do it. But we know very well that it is one of the things to be looked into further is with staple fiber. But it is possible, for example, also with the PLA.
Thanks. And I see like lots of questions in the chat. That's amazing. I hope you still have like a few more minutes, Guy. Okay, so then we have another question about what are the identification test methods, whether it's bio-based or not?
It's bio-based or not? Good question. Normally one looks there to the carbon content. So you can measure the difference between the carbon coming from fossil or from bio-based. And so there are some specific certification methods for that say about the bio-based. It's not something we did in the project. There are some test methods for producers of the bio-based materials who can get a certain percentage then of bio-based.
Okay, thanks. The next question from Esther is it possible to learn more about your findings on bio-based inks or coatings concerning its material resource, which fabric supports are suitable, for example, natural versus thermoplastics, but also structure and elasticity, its circular end-of-life possibilities, especially recyclability, biodegradability, etc.
Yeah, well, the first I would say to learn more about it, I will advise again the resources hub that we made have from HEREWEAR. I saw also, thanks Link for putting the link there. When it comes specifically to the material we used, so we had two bio-based polyesters, the PLA and the PHA that we used, and it can be done on different fabrics. Elasticity works up to a certain degree, but of course, if you have a coating, it is not that the material remains, let's say, endlessly stretchable. So it's there one has to have realistic possibilities. When it comes to the recyclability, biodegradability, I think that depends largely on which combination you have of the coating print within the substrate. And indeed, in some things, one can think about targeted biodegradability of some parts. For some things, you can also look into really a removal of the coating, so a kind of debonding step, if there would be some help. I think there are different options, and depending also on the application. But I would say if there's some more specific interest is needed, you probably also saw the sign of patent pending, but feel free to contact and we can discuss them more in detail.
Great. And then I think, I think I'll take like one more question and possibly the others. I think there was your email in the chat somewhere. Yes, Lien shared your email. So possibly after this one more question, everyone else, if you would like to ask your questions, feel free to reach out to Guy so we don't take too much of your time. I hope that's okay. So the lucky one with the last question is did you explore how the quality of bio-based fibers deteriorates when they are recycled or reused?
Up to a certain extent, yes. Maybe it was because I showed a lot. What I would first say is that when I showed the value chain, you could see that the dots for the actual recycling and so, or the lines, they were dotted because the actual recycling processes were not part of our project. So that, but we did do some external tests. And of course, if you like chemical recycling, you basically reset the material. If one does like with the thermomechanical recycling, what we learned, of course, will be that it depends on the status of the material when you get it back. So there might be an influence with contamination and so. But if you look in general, when things are recycled and with the amount of recycled content that is now typically used into new products, that let's say if you can show that the material lasts something like for 5 cycles, where it's being reused, for example, with the thermomechanical process, that should be sufficient. And then for the materials that we have, that should be feasible. What we did not do is explicitly, let's say, under different conditions, test recycling or with contaminants and so, because our main goal was to see what's possible with the material and to make the design as such that, let's say, at end of life, it can be recycled. But again, very willing to offline continue more about the results that we obtained there and also options we see.
Amazing. Thank you so much for answering all these questions and sharing your results. I just will quickly wrap up this webinar. I feel quite sorry that I have to disrupt here, but let's bring this webinar to a close. It's great to see that all of you are so interested in the work that the projects are doing. We just finished the Q&A. So I just wanted to briefly share the upcoming activities and events from both ECOSYSTEX and a few of our member projects. The next Insight series will take place on the 31st of January, and we'll share the agenda and registration link in the upcoming weeks. The one afterwards will be in March, like in early March or April. And then on the member project sides, we have 4 different events upcoming still this year. So there's the Self-Will project being present at the Research Technology and Innovation Highlights from the Bio-Based Industry 2024 event in Vienna. That one will be in German only, both in person and online. We have the 0F project participating at the Anticipatory LCA to promote informed decision-making workshop on the 4th of December, which will take place online. And then the Surpass 2 project is currently promoting a survey from the European Commission for digital product passport service providers that are asked to submit their feedback by the 10th of December. So if you work on that, that's a good opportunity to make yourself heard. And then lastly, the T-Rex project is participating at an event called Advancing Polyester Textile Circularity, Coordinating Scaling Across the EU Value Chain for a Robust Infrastructure on the 11th of December, also online. And last but not least, I just wanted to flag to you that we at Textile ETP are organizing something that is called the Circular Bio-Based Textiles Innovation Hub that brings together European textile sustainability experts to learn, network, collaborate on the hot topics of circular and bio-based textiles. And we will publish the program for next year in mid-December. So I invite you to follow the Innovation Hub on LinkedIn to stay informed about that. And if you are in ECOSYSTEX, there's a 10% discount until the end of the year for you. But my colleague will also send you an email about that. And this is really a great way to meet experts from all across Europe and deep dive into specific topics. And it's really interesting. My colleague, I think, will also drop a link in the chat where you can see what we did so far this year. So that gives you an idea what our program usually looks like. And then last but not least, if you're not yet connected to ECOSYSTEX, of course, I invite you to also follow us on LinkedIn and also check out our beautiful new website that my colleague Charlotte designed. And there you can find all our member projects, but also a sort of database of public deliverables from all our member projects. So it's a nice go-to site now if you're interested in current research and innovation. And of course, if you are working in an EU-funded research project that is focused on textiles, do you think you might like to join the community? Of course, you're also very welcome to send us an email, and then we can explore that further. And with that being said, I would like to thank all of you for staying with us this long. Sorry for being 10 minutes over time. Thank you again also to all our speakers, really lovely presentations, and yeah, wishing you a great Friday and a nice weekend afterwards. Thank you so much for joining. See you next time. Bye.